So, Physics 2211, Lab 3, Black Hole and Orbits. Introduction. The purpose of this lab was to simulate the orbit of a star around a black hole with unknown mass by plotting its trajectory using code and web Python. And then we found the mass of the black hole using concepts that we have learned throughout the course. Part 2, we were in a scenario where we're on a spaceship that's in the orbit of a planet and its moon. We're on top of the moon. We want to try to blast off that moon and find the initial velocities to make our spaceship go in a figure-8 orbit around the two masses. Concepts used in the lab, we have Newton's second law. We also have two concepts we learned recently, F-net parallel, which is the change in the magnitude of the momentum, and then we have F-net perpendicular, which is mv squared over r. R is the radius of the Kinsey circle, and we have force of gravity and velocity update and position update. These three that we used in previous labs. So, coding part 1. The goal here was to find the mass of the black hole. We know that the mass of the star was 2.0 e to the 30, which was given to us in the lab instructions. And so we want to find the F-net here. So we know that since the star was going to be in a circular orbit, that F-net was just going to be the F-net perpendicular. So we were given the mass of the star, its velocity was generated unique to us because of our email, and then we could set F-net was equal to the F-net perpendicular, and using that we could find for big M, which would have been the black hole's mass, and that's why we have MBH equals mag F-net times mag star pos times 2 over the mass of the star times big G. So using that, we found the mass of the black hole, and we also plotted the trajectory of our star. So here's what we have right here. This is the black hole mass ended up being 2.11 e to the 34th, and then our trajectory was like this. Yeah, so we have our arrow vectors that show us F-net perp, F-net parallel, and the F-net. Alright, so part two of this was to find the velocity that we need to blast off the moon to get in a figure-8 orbit. So we want to find the net force on the moon from all the factors, which were the spaceship and the planet. We want to find the net force on the spaceship, which was the force from the moon and the planet, and then we want to find F-net. So that's why we have F-net ship is F-net planet on ship and F-net moon on ship. So we find that, and then after finding F-net, we're able to plug it into the velocity update and position update formula, and then we plug in test velocity to see if we can get a figure 8. So I was unsuccessful here. I ended up getting something that looked like this. It didn't look like a figure 8 to me, but I tried my best. So I settled on the initial velocity of negative 19,000 in the x direction and 24.5 thousand in the y direction. So this is actually, I can show you the trajectory of my spaceship. So go in a weird orbit around the planet, and it picks up a little bit of the gravitational pull from the moon. We almost crash into the moon. Everyone almost dies, and then we exit the orbit and go infinitely in the negative y direction, which is a lot of fun. Alright, so discussion. What does it mean? So what is the net force? Net force is the spaceship. The net force on the spaceship is the combined gravitational forces from the moon and the planet. There's also a net force on the moon from the planet too. And there's also a net force from the spaceship on the moon, but it's very negligible. So the parallel component. So what's the difference between the net force and the parallel and the perpendicular components? The parallel component is a change in the magnitude of the momentum, and the perpendicular changes purely the direction of the system. And here's important because it sets the trajectory for the spaceship. Discussion, what if the imaginary system has a black hole, yada yada yada. So the black hole would have a strong gravitational force, and it will change the trajectory of all the systems. It's possible that the black hole would probably cause all the orbits to fail, eating the spaceship, planet, and the moon. Everyone dies. And then calculate the trajectory of everything that we need to find the black hole. We need the distance r of it relative to the spaceship, planet, and the moon. Thank you.